When it comes to maternity dosage calculations, don't panic. The math is the same as in other areas of nursing. You will often see oxytocin administered in maternity, as well as magnesium sulfate and some other medications. Oxytocin is usually ordered in milliunits per minute, but because most pumps are set for milliliters an hour, the nurse is tasked usually to convert those milliunits per minute into milliliters per hour. Sometimes your order will have multiple components. For example, you will have to administer a bolus of medication followed by a maintenance dose that goes continuously for several hours. Let's not be intimidated by milliunits. 1 unit equals 1000 milliunits, just like 1 gram equals to 1000 milligram, and just like 1 liter equals 1000 milliliters. There's nothing complicated about milliunits. Here's our first maternity problem. Induce labor with oxytocin 15 units per liter IV continuous infusion at 2 milliunits per minute. Increase by 1 milliunit per minute. We call this part titrating it. When we're increasing or changing the rate, we're titrating the infusion. So we're increasing by 1 milliunit per minute every 30 minutes to a maximum of 20 milliunits per minute. And the first question, this problem will have several questions. The first question we're going to answer is the initial concentration of oxytocin in milliunits per milliliter. That's what we need to find. Look, initial concentration of oxytocin is given to us in units per liter, and we are asked to find milliunits per milliliter. And remember, the conversion factor for our milliunits from units to milliunits is 1,000, right? Just like from gram going to milligram, from liter going to milliliter, it's 1,000. So if we have 15 units to figure out how many milliunits it is, using DKP method, I'm going to write first, what do I know about units and milliunits? And I know that 1 unit is 1,000 milliunits. I need to find 15 units. I carefully put my units under units, milliunits under milliunits. So 1 unit is 1,000 milliunits, 15 units is X milliunits. And when we use DKP method, we carefully check, do I have units under units, milliunits under milliunits? Next, I find a diagonal that's not an X. And I multiply these two numbers, and I divide by the third number. In this case, we have 15 times 1,000 divided by 1. And I got 15,000 milliunits. So next, going from units per liter to milliunits per milliliter, I need to convert my liters to milliliters. 1 liter is 1,000 milliliters. I already converted it in my head, and I'm gonna write down that 15,000 milliunits, which used to be 15 units, right? We just converted per liter or per 1,000 milliliters. I'm going to write that down. So what I wrote is my 15,000 milliunits is in 1,000 milliliter. I need to find what is it per milliliter, right? The question is asking me milliunits per 1 milliliter. 1 milliliter, I'm putting milliliters under milliliters, is X milliunits. So 15,000 milliunits are in 1,000 milliliters. What is it per milliliter? Again, I'm going to multiply on diagonal and divide by the third number. 15,000 times 1 divided by 1,000, giving me 15 milliunits per milliliter. I know I found milliunits because I set my X under milliunits, and I know it's per milliliter because that's what I was looking for. We answered question A. Let's go next to question B. The next question for the same problem, question B, the initial oxytocin order will infuse at the rate of how many milliliters per minute? And we see that our initial order, continuous infusion, is 2 milliunits per minute. We need to find how many milliliters per minute is that, right? It's given in milliunits per minute. We need to go to milliliters per minute. We're going to write down using DKP method. Just what we need to find out. 2 milliunits that are going per minute. We need to find how many milliliters is that. 2 milliunits is X milliliters. What we just found in question A is that 15 milliunits is 1 milliliter. 2 milliunits is X milliliters. 15 milliunits is 1 milliliter. We check in ourselves. Do we have milliliters under milliliters, milliunits under milliunits? We multiply on diagonal. We divide by the third number. X equals 2 times 1 divided by 15. And that equals to 0.13 milliliters per minute. Question C. Regulate the infusion pump at how many milliliters an hour to initiate the order? Remember, the pumps are just machines that nurses program to deliver certain number of milliliters per hour, and they usually understand only milliliters per hour. We call it the flow rate. How many milliliters per hour? Now, if your order is given in milliunits per minute, you need to figure out how to tell the pump to deliver correct number of milliliters per hour. In question B, we just found that 0.13 milliliters are going over 1 minute, and that will help us to find what is it per hour. Let's write down what we know. And we know from question B that we just calculated that 0.13 milliliters is going over 1 minute. To find milliliters per hour, I'm going to say I don't know how many milliliters are going over 60 minutes, which is an hour. I'm using minutes because in DKP method, we only can use minutes under minutes, milliliters under milliliters. I cannot put hour under minute, right? They have to be the same measure. So 0.13 milliliters is over 1 minute. X milliliters is over 60 minutes. Multiply on diagonal and divide by the third number. (0.13 times 60 divided by 1 is 7.8 milliliters are going to go over 1 hour. I'm going to go ahead and round it to the nearest whole milliliter. 8 milliliters are going to go over 1 hour. And the last question of this problem. D. The infusion pump will be regulated at a minimum of how many milliliters per hour to infuse the maximum of 20 milliunits per minute. Because the problem is giving us the maximum of 20 milliunits per minute that we can infuse, right? So what is it in milliliters per hour? And if the numbers given to you are as simple as here, you can right away see in question C, we found that the initial infusion of 2 milliunits per minute, we found it to be 8 milliliters per hour. Here we have 20 milliunits per minute, so it's 10 times that. We can just do 8 times 10, get 80, and that will be correct answer. But what if the numbers were not so easy? How do we set it up? We're going to set it up using DKP method. We're going to say 20 milliunits are going over 1 minute. 20 milliunits is 1 minute. What does it mean per hour? X milliunits is in 60 minutes infusing. So 20 milliunits, 1 minute, X milliunits in 60 minutes. I'm trying to find how many milliunits are going to go over 1 hour. Multiply on diagonal, divide by the third number. Twenty times 60 divided by 1. And I get 1200 milliunits will be infusing in an hour. Now I need to find milliliters, right? Because it's not asking me milliunits per hour, but milliliters per hour. And remember, we already found that 15 milliunits is 1 milliliter. So how about 1200 milliunits? How many milliliters is that? 15 milliunits is 1 milliliter, 1200 milliunits is X milliliters. Multiply on diagonal, divide by the third number. So 1200 times 1 divided by 15. And I got 80 milliliters per hour. We answered question D. Here's our next problem. Magnesium sulfate bolus, 5 gram, is ordered for a patient with preeclampsia to infuse over 30 minutes. The ordered maintenance dose is 3 gram per hour for 12 hours as tolerated. Available magnesium sulfate 50 gram in 100 milliliters, and we have two questions. A, calculate infusion rate in milliliters an hour for the bolus, right? We have a bolus and we have a maintenance dose. We have two things to worry about here. So first we need to find milliliters an hour to plug into the pump for the bolus, and B, infusion rate in milliliters per hour for the maintenance dose. So same thing for the maintenance dose. Let's do one thing at a time. We're going to start with A. So for infusion rate in milliliters an hour for the bolus, let's only concentrate on the bolus information that's given in our scenario. Okay, bolus 5 gram for a patient with preeclampsia to infuse over 30 minutes. So 5 gram is going over 30 minutes. How many milliliters an hour is going? I'm going to start with my time, because to find milliliters per hour, I need to go ahead and change this to per hour. Using DKP method, I wrote 5 gram is going over 30 minutes. How many gram or X gram is over 60 minutes or per hour? Multiply on diagonal, divide by the third number. And I get 10 gram is going over an hour. Now, if the numbers are so easy as 30 minutes compared to an hour, you can see right away, you can just double this 5 gram and get your 10. But what if it's 15 minutes or 45 minutes or some other number of minutes that are given to you that are not so easy to do in your head? This is how you will set it up. So 10 gram is going over 60 minutes or over an hour. Now, what is it in milliliters? And to find that, we need to go to our available concentration and see that 50 gram is in 100 milliliters. We're going to write just like that. 50 gram is 100 milliliters. We need to give 10 gram in an hour, right? How many milliliters is 10 gram? Multiply on diagonal, divide by the third number. And I get 10 times 100 divided by 50. And I found 20 milliliters. I set my X under milliliters, so I know I found milliliters. That's how many milliliters per hour I will be given as a bolus. I will set on my pump, 20 milliliters per hour. So we figured A, now let's figure B. Infusion rate in milliliters per hour for the maintenance dose. Now throw away everything about the bolus. Only focus on the maintenance dose. We're receiving 3 gram per hour for 12 hours is tolerated. So 3 gram per hour, what is it in milliliters per hour? It's already per hour, so we don't need to convert any minutes to hours like we did here. So we only need to use our concentration to find 3 grams. What is it in milliliters? And our concentration is 50 gram is 100 milliliters. We need to give 3 gram. How many milliliters is that? Multiplying and dividing. And I get 3 times 100 divided by 50. And that is 6 milliliters per hour I will be programming on a pump as a maintenance dose. 20 is my bolus and 6 is my maintenance dose. Here's our next problem. The order is to administer oxytocin to induce labor. Start infusion at 0.5 milliunits per minute and increase by 1 milliunit every 15 minutes. We call this titration when we change the rate. Available oxytocin 10 units in 1 liter of normal saline. Calculate the initial infusion rate in milliliters per hour. So this is the initial infusion rate, 0.5 milliunits per minute. And this is how we will be increasing that rate. Question is not asking us about increasing anything. So this information right away becomes irrelevant. And we can erase it and not worry about it. All we need to understand now is that 0.5 milliunits are going per minute. What is it in milliliters per hour if this is available? And remember that 1 unit equals 1,000 milliunits. Just like 1 gram equals 1,000 milligram, 1 liter equals 1,000 milliliters. So let's start by writing that. One unit is 1,000 milliunits. I have to administer 0.5 milliunits. I'm putting my milliunits under milliunits. How many units is that? Multiply on diagonal, divide by the third number. 1 times 0.5 divided by 1,000 gives me my X, which is my initial oxytocin in units now. And why am I converting it to units is because concentration of oxytocin is given in units, not milliunits. So I want to bring it to the same unit measure. So 0.5 divided by 1,000. I get 0.0005 units. This is how much my initial infusion will be in units per minute. Now, I need to find infusion rate in milliliters per hour. So let's go to hour. This is still per minute. Now, to get me to hour, I just need to multiply by 60. When I multiply this by 60, I get 0.03 units, and that's now per hour. Okay, now I can use this and plug it into my concentration to find how many milliliters an hour to set on a pump. Now, concentration is given in units per liter, and I know that liter is 1,000 milliliters, and I'm going to write it like that. 10 units is 1,000 milliliters. I need to give 0.03 units in 1 hour, right? Units under units, milliliters under milliliters. So 10 units is 1,000 milliliters, 0.03 units is X milliliters. Multiply on diagonal, divide by the third number. X equals 0.03 times 1,000. And all of that divided by 10. 0.03 times 1,000 divided by 10 is 3 milliliters per hour. This is the initial infusion rate that I will set on the pump. Many more maternity problems you will find in my book, Dosage Calculations, Getting It Right Every Time. In the comments below, please let me know what other dosage calculation problems you want to see in the next videos.